What we're going to do really quickly, guys, I've written down all my answers to most of my answers to multiple choice questions, but I wanted to go through and explain some of them to you, okay? So, really quickly here, I'm just showing you the point, my main point, which is you guys need to show all of your work, all right? So, even though I'm doing something as simple as going from moles to molecules, I still need to show I need you to show all your work so I can give you full credit. So, this will get full credit, not just D. D, you only get half credit. Okay, for number 11, it's really nice and simple. I tell you, I'm sorry, the subscripts got messed up on all of these, so I give you only the important information. I tell you that in one molecule you've got 7 hydrogens, so common sense should tell you that if you got 5 molecules, then you would have 35 hydrogens. Okay, diatomic elements, we've gone through that. That's the 7 that's made on your periodic table. It includes nitrogen, oxygen, chlorine, bromine, iodine, one more that I'm forgetting on that side, and hydrogen. All right. The other thing, so I mean that's all that you need to remember about that. Okay. Number 13, with Avogadro's number, remembering the fact that with elements we're talking about atoms, with compounds we're talking about molecules. Okay, we're going to use the term atoms when we're talking about that 6.02 times 10 to the 23rd. We're going to use the unit atom only when we're talking about elements. And we're going to use 6.02 times 10 to the 23rd molecules only when we're talking about compounds. All right, which means if I've got 1 mole of Br2, which is an element, I need to be talking about atoms. So that works perfectly. That's the right answer. I need to be using those terms. If I have the element Au, I should be talking about atoms. That's perfect. That works great. If I've got N2, which is an element, I'm not talking about molecules. I'm talking about atoms. So that's wrong. That's why it's C. All right. Here for 14, it's still very simple, right? The 1.8 times 10 to the 20th, trying to convert that to moles. Make sure that just because it's 0.0003, that you don't freak out and think that none of the answers are there. Remember, you can just move your decimal place over 1, 2, 3, 4 places, and you've got 3 times 10 to the negative 4th. Okay, not too bad, hopefully. Here you're just finding the molecular mass. Just remember you've got 2 nitrogens, 8 hydrogens, 1 carbon, and 3 oxygens, if you didn't get that answer correct. All right. For here, same thing, 5.9 moles, you need to convert that to grams. You need to show your conversion, or else I can't give you full credit. All right. Here you've got 36 grams, same thing, crisscross swish, show how you get from grams to moles. All right. For 18, it says, for which of the following conversions does the value of the conversion factor depend upon the formula? So think about it. When do we care about what the formula of the substance is? Well, if we're going from volume to moles, the conversion factor that we always use is 22.4. So it doesn't matter. It's always going to be 22.4. So that one's wrong. For density, well, we haven't been talking about density, so please don't bring up something like density when we haven't even brought it up. For mass of a substance to moles, think about it. When we're going from mass to moles, we need to use some molecular mass, and that depends on the identity of the compound. So yeah, we are worried about the formula of a substance. All right, and just for the record, for D, it's the 6.02 times 10 to the 23rd. So that doesn't rely on it. So C does rely on the formula of the compound. All right, the molar volume is the 22.4. Remember, 1 mole occupies 22.4 liters. So that's that ratio that we use. 1 mole equals 22.4 liters. All right. Which of the following gas samples would have the largest number of representative particles? Remember, I changed this to atoms. Okay. So remembering that, one sec. If I'm talking about A, B, or C, all I need to do is go from, and I'll just show this conversion right here, liters to moles. And then from moles to atoms. It's really nice and simple. I can do that. However, if I'm given SO3, which I am in D, you can't go straight from moles to atoms. You're not allowed to do that. So you're going to have to do one more extra crisscross swish, which is a pain in the butt. Sorry about that. So you're going to go from moles. You have to go from moles to molecules first. M-O-L-E-C, molecules. Then you're going to go to atoms. Okay. This is all the same stuff that we've been talking about, nothing new. 6.02 right here, the 1 here's the new relationship. Well, in one molecule, not in one mole, in one molecule, you've got, well, 1 sulfur, 3 oxygens, you got 4 atoms total. Okay, so that's something new. That's probably wouldn't end up on the test, but it could definitely be a extra credit problem. Okay, when you have 60.2 grams, we're going on and talking about percent composition. Now I'm giving you grams rather than just giving you the molecular mass. What I want you to find now, you need to take these two masses and add them together to get the total. So what you'll end up getting is 84.2 grams. That's your total. Okay, now if I want to find just the percent that's Hg, then it's going to be 60.2 because that's the amount that Hg contributes out of the 84.2. So I'm going to take this in my calculator really quickly. I'm going to take 60.2 divided by 84.2, and I end up getting 71.5%. So I end up getting C. And that works out perfectly. All right. Which of the following is not an empirical formula? Remember, guys, an empirical formula is the lowest whole number ratio. Okay, so what that means is an empirical formula is anything that I cannot reduce. So if you look at A, I can reduce that. And look at your sheet because this one's bad to look at. But this is C2N2H8. I can reduce that, which tells me this is not an empirical formula. Okay, the other ones I cannot reduce. All right, which is the empirical formula? And I give you these percents. Remember, the steps you need to take are the following. If I give you percents, you need to convert these to grams, and it's really easy. It just becomes 40 grams and 60 grams. Really not bad at all. Okay, then you need to convert that to moles. Okay, and once you're in moles, divide by your smallest number of moles, and what you'll find, believe it's C, your answer is SO3. Okay, which of the following is not true about empirical and molecular formulas? Okay, the molecular formula of a compound can be the same as the empirical formula. Oh, absolutely true. If your multiplier ends up being 1, right, like that problem we did with N2O5, then yeah, your empirical formula will be the same as your molecular formula. That's fine. The molecular formula of a compound can be some whole number multiple of its empirical formula. Absolutely. You can have a 1 multiple, you can have 2, 3, 4. That multiplier will change and determine what your molecular formula is. So B is perfectly fine. Several compounds can have the same empirical formula, but have different molecular formulas. So for example, NO could exist as N2O2 or N3O3, for example. Obviously these don't really exist, but those are examples of what could happen. So yeah, that's fine, right? Same empirical formula, different molecular formulas. The empirical formula of a compound can be triple its molecular formula. That's not true. Your empirical formula will always be smaller than your molecular, right? This couldn't be the empirical formula of this. This couldn't be the molecular and this the empirical. This would always have to be the molecular and that the empirical. Okay? What information is needed to calculate the percent composition of a compound? The weight of the sample? Well, no, we haven't been talking about weight and density, so no, that's not necessary. Okay? Do we need the molar volume and the weight? No. Okay, the formula of the compound and the atomic mass. Well, if you think about it, when I gave you, for example, just H2O and asked you to find the percent composition, all you knew was the formula and the atomic masses of each of these. So yeah, that's exactly what you need. So C is the answer. Okay. What is the empirical formula of a substance? And I give you all 3 of those things. So remember, what you have to do is the following. You need to convert from grams to moles. So you've got the 53.5. Oops. Now it's going to stop working all of a sudden. 53.5 grams. Okay. You've got the 15.5 H and you got the 31.1 nitrogen. So what you need to do, crisscross swoosh with all of these, find your number of moles. And what I end up getting is I get C2, hold on one sec, C2H7N. So if you notice the answer C, I made a mistake though. Sorry about this. This is hogwash. This should not be 8. This should be 7. So if you could correct that, that would be awesome. So the answer C, except that should be 7 and not 8. All right? And that's the end of the multiple choice, guys. If you can do this, you can do anything that I asked you guys on the test.